Hi, everybody. Welcome to truthcourt.net, home of the Internet Court of Truth. We're thrilled by your interest in what we're doing, and we're happy that you're giving us a chance to showcase our work. Did you ever come across a dubious claim online? Sure you did. Truth Court is here to help with that. We offer a platform where anyone can scrutinize statements like that and determine their authenticity. The way it works is very similar to a traditional civil court, complete with plaintiffs and jurors. So here's a rundown of how it all works. First, spot a questionable claim online or in the media or anywhere, something that's bothering you or something you've seen. Head to truthcourt.net, sign up as a plaintiff. If you're not a member, sign in. It's very easy, it's quick and free. And once you're a member, sign in as a plaintiff and create a case about the statement that you've heard on the media or online, and you can posit whether you think it's the truth or a lie. The next step is that you will respond to 8 universal verdict questions designed to dissect that statement. Now, we have very carefully thought about questions that will kind of act as a universal determinant that will let you think about the statement and put in some opinions about it. So once you've answered those 8 universal verdict questions, we need to get some jurors for you. So you will invite at that point others to act as jurors on your case. And you'll invite them by email. Up to 8 at a time can participate. You can invite more than that, but only the first 8 will get to participate. Once the jurors get their invitations, they'll click the link and they'll be taken to your trial. And they then have the pleasure of answering the very same 8 questions about your statement that you answered. They're going to put their answers into those 8 questions. When it's all over, you get to review it all. You get to look at the other jurors' answers, and you're going to discover what they think about your claim. And hopefully you'll gain a little insight into their reasoning as well. Be prepared for surprises. You think you know people. I can assure you that once you get some of these verdicts in, you'll be surprised. Optionally, once you're done with your case, you can share it on social media. It's very simple. All you have to do is click a button and pick your social media platform. Only you have the power to do this. And after you've done it once, do you want a do-over? Well, that's easy enough too. You can click a retrial button. The system will set up your case, the same case that you set up a new case based on your previous one. And you can tweak the details and change a few things, or you can retry the exact same case. You can invite the same people. You can invite different people. I think it'd be more interesting to invite different people and find out what others think about that claim as well. So that's how it works. Just so you know, though, Truth Court's role is to facilitate the process. We do not influence the case content or any of the answers. All of those outcomes are shaped by your jurors and you. The things that you put in, that's up to you. We have no input into that at all. So for a detailed procedure, why don't you jump over to truthcourt.net. You'll see there some sample cases on the homepage you can look at and see what it all looks like. And even better, stay on with me now, and we're going to do a case. So I'm going to share my screen, and I'm going to run over a case with you that I put in. And it's an interesting case, I think. It's based on a Ray Bradbury short story. For those of you who may not know who Ray Bradbury is, he was an iconic science fiction writer. And he wrote a lot of provocative stories, a lot of interesting stories. But this one in particular I've chosen because it's short and easy, quick to read. And also it raises some very interesting issues. The title of the story, or the trial that I'm bringing today, is Non-Science in an Iconic Ray Bradbury Story. Little play there on nonsense in an iconic Ray Bradbury story. Now, before I jump into that, I want you to take a look here at the screen you're viewing. This is the case record screen at Truth Court. And if you look over in the left-hand column, you'll see status, tells you some things about where we are with the case. The trial is in progress. how long it is, the date. You'll notice there's a link here that says conference link. There are a number of folks on Zoom with me right now live with this case, and you have that option too. When you create a case, you can set up a Zoom meeting for this time and send it along with your invitation so that when your jurors join, they can actually take a look by clicking on this, join a Zoom link, and you can talk to them live. Over here in the far right column, these are the 8 questions we're going to answer, and we'll get to them in a minute. In the middle are the case details, and I'm going to go over these with a little bit more detail so that you know what we're talking about. First of all, the story, the name is Non-Science and an Iconic Ray Bradbury Story. The category, I'm calling it Science Missteps for the Sake of Plot. Now, I am asking my jurors to read the story. And at the very bottom of this column, I have a URL that contains a link to a PDF of the story. So I wanted everyone, my jurors especially, to read the story before they went further. It's a brief story. It took about 10 minutes to read, so it's not a complicated thing to read either. All right. The story that is in question is called A Sound of Thunder by Ray Bradbury. It's an iconic science fiction short story. It explores time travel and something called the butterfly effect. And we'll get into what the butterfly effect is in a minute. Set in the future, the narrative follows a man named Eccles, who pays to embark on a safari through Time Safari Incorporated. So in the story, Eccles signs up to go hunting in the past for big game. He's guided by a guide, Travis. He's the safari leader. Eccles is told before he goes on his time travel into the past there are going to be some very strict rules in place, and he has to avoid doing anything that could alter the past because it might alter the course of history. Well, as the story goes, they journey back 60 million years to a prehistoric era, and the hunters are instructed to shoot only animals that have been marked with red paint by Time Safari scouts who have gone back in time ahead of Eccles. So he's going to shoot a dinosaur. Tyrannosaurus Rex, I believe. Eccles is overwhelmed by the awe-inspiring reality of time travel. I mean, and who wouldn't be? You step back into a time 60 million years ago. And as a result, he inadvertently steps off the designated path that he's supposed to stay on. And this introduces the possibility then in the story of disrupting the natural order. The narrative takes a dramatic turn when Eccles unknowingly kills a butterfly. He stepped on a butterfly, seemingly inconsequential act that triggers unforeseen consequences. So Eccles goes through, gets back on the path, shoots his dinosaur. They come back to the future, or to the present, actually. And upon their return to the present, Eccles discovers that things have changed dramatically. Alterations in language, a shift in political leadership. The story concludes with a tragic revelation about the impact of Eccles' seemingly small actions on the course of history. So A Sound of Thunder as a story delves into the consequences of tampering with the past, emphasizing the fragile interconnectedness of events and the potential far-reaching effects of even the smallest disruptions in the timeline. It's a great story. It's a very interesting story. Not only captivates with its exploration of time travel, but it also invites scrutiny for its scientific conjectures. Of special interest are the possible inaccuracies in Bradbury's portrayal of time and the liberties he takes for the sake of storytelling. He expertly creates tensions between scientific accuracy by doing this, and the narrative demands it makes a wonderful tale. So the effectiveness of the story rests on the concept of the butterfly effect. And what the butterfly effect is that if you go back far enough in time, even a very minor thing like stepping on a butterfly can have very big effects down the road as time travels on. There are some flaws in this theory, however. The first one I say is deterministic time travel. The story implies a deterministic view of time where events in the past are fixed and unchangeable. If this were the case, a butterfly killing a butterfly could have immediate effects. However, our modern understanding of time travel, if it were even possible, It's highly speculative, and there are a lot of different theories about how it might take place. And the butterfly effect is by far is certainly not a proven concept. Exaggerated impact. It suggests that the death of a single butterfly in the distant past would have a far-reaching catastrophic effect on the present and future. Well, the butterfly effect is a real concept in something called chaos theory. And chaos theory says that if you know the exact state of a place or a time, and that means everything about it, and you know all the processes and the equations that describe them that govern that, you could predict what was going to happen. But the reality is it's highly unlikely that we could ever know the exact state of any time, let alone something 60 million years ago. So it's probably highly unpredictable that this could happen, and probably not probable. The story also introduces something called, or some paradoxes about the fact that time would step aside to prevent paradoxes such as a person meeting their past self. This concept is not consistent with time travel theories and raises questions about the nature of time and causality. Story's portrayal of time seems to bend to the convenience of the plot. Nothing the matter with that, but I don't think it's a portrayal of exact science or good science even. And of course, the unrealistic time travel technology, a machine that can take us back with a great deal of specificity to an exact moment in the past. It's highly improbable in my mind, and it's not supported by current scientific understanding of how these things work. The story also takes in a linear view of time, where it's a past, present, future. Everything goes in steps. That doesn't jibe with some modern physics theories. Multiple timelines, multiple universes, parallel universes. There can be more than one timeline. So the linear view of time is something that's really not supported by modern theory also. So it's a good story. It really is. But it breaks a lot of scientific rules, in my opinion, or at least bends them very strongly. But Bradbury used them to great effect in talking about the consequences of our actions, that even small actions can have major consequences. And that's the gist of the story, whether or not the science was correct. So that's my story. That's my case. That's what I'm going to talk about. In my next field down here, it says markup. I've selected a statement that was in the story. And here it is. I'll read it to you. This is a verbatim quote from the story. It fell to the floor, an exquisite thing, a small thing that could upset balances and knock down a line of small dominoes, and then big dominoes, and then gigantic dominoes, all down the years across time. Eccles' mind whirled. It couldn't change things. Killing one butterfly couldn't be that important, could it? So this is a quote from the story. You notice there are little buttons up here marked lie and truth. I had the option of highlighting this and mark it a lie or a truth, but I think that would be a less productive way to talk about it than to just put it out there as a statement, and we'll discuss it over here in our 8 questions. All right, I'm going to move to my 8 questions now. And if you'll notice, I'm looking over here in the left-hand column. I have 4 jurors who've accepted invitations to be on this case. 2 of them have finalized their verdicts. The other 2, I presume, are working on theirs now. So we'll find out. Hopefully, if you're a juror, please complete your verdicts and push the button at the bottom that says you're done. Okay, is it the truth? And this is the statement we're talking about here, this quote that I read to you. Is it the truth? Well, I'm the plaintiff, and I say, no, it's not the truth. And I'm fairly confident, about 75%. The premise that killing a prehistoric butterfly can alter the present is probably not true. It might be, but it's probably not. Nonetheless, Bradbury makes masterful use of the notion to produce a thought-provoking tale. Is it the whole truth? Again, I say no. Even though the story science may be inaccurate, though, it reverberates strongly, making readers consider the effects of their own seemingly inconsequential actions. Is it nothing but the truth? Again, I say no. There may be elements of truth in the butterfly effect, but our understanding of time is rudimentary at best. There's likely much more to be learned if, in fact, such things are knowable at all. What is the deceit? Well, one possible deceit is that the butterfly effect is true. I don't think it necessarily is. But even if it's false, it's undeniable that our actions have far reaching and unforeseen effects. So it's hard to say, even if there is a deceit. Is the deceit or truth intended? In my mind, I'm saying, yeah. Ray Bradbury purposely used this plot device and probably didn't worry too much about whether it was true or false. It was a good plot device for him to tell a great story and to bring about some issues that would be difficult to discuss any other way. So I think it was an intended use. What's the motivation behind it? Who knows? Bradbury's motivation may never be known. In my view, following in Roland Barthes' theories, for the most part, an author's motivations are largely irrelevant, since every reader recreates the story when they read it, and in effect, you're actually rewriting the story every time you read it. So I don't think we'll ever know what the motivation is, and I don't think it's important actually that we know it. What's the social acceptability of the truth or lie? Yeah, I say it's acceptable. Whether the butterfly effect is true or false, the story offers a thought-provoking scenario that has many profound implications. And finally, what label would improve the acceptability of this truth or lie? Well, since I don't know if it's a truth or lie or not, I'm not sure if it even needs to be labeled. If you saw this statement somewhere over here, this thing over here that I've right over here, if you saw this statement, what label I would put next to it is read the story that contains this quote and draw your own conclusions. This story demonstrates the power of science fiction to raise important issues. So there we have it. That's my my case today. It's a discussion of the butterfly effect. I see we still have a couple of jurors working on their case, on their verdicts. So while they're still continuing to work on their verdicts and finish them off, I would ask my jurors if any of you two who have already done your verdicts, would you like to make a comment about them while we're waiting for the other two folks to finish?
So I would, unless somebody else wants to jump in front of me, but
Go ahead, Bob.
Sadly, I understand the physics. Okay. And what Bradbury's, oddly, I wrote an article on the physics about 3 weeks ago before I even knew you were going to do this, Frank. Okay.
Well, Bob, that's why I chose this live today after I read your article.
Oh, really? Okay.
Yes.
So what I'm going to do is I'll bring. It turns out that the only thing that relativity really predicts is a time slowdown of one participant with respect to another participant. But for any specific participant, you can't go back in time and meet yourself. That's just not possible. Okay. When you go back in time and meet yourself, you're not meeting yourself. You're just living your life. Okay. Time is always going forward at the same speed for the participant. It never changes for that participant. Only his perception of the time that another participant has gone through, okay, which can be real, but you really can't meet yourself. And it turns out that modern physics makes this really impossible. And what I'll do is I'll share that article that I wrote that you read that, and just explain why physics says this. And it's a pretty amazing thing that it says, that and this is Einstein, so there's no change from 1904. You know, it's relativity. Uh, it's what it always said when Bradbury was writing his thing, but people just didn't understand it in terms of modern physics. So I'll share this. I cannot. Uh, oh, could we get this so I can share this screen fairly? I can't. I can't do anything with it. Tell me when it's ready. Um, uh, and what I'll do is I'll bring up the actual physics, and it's actually incredibly simple. This is the graph of, of, of approaches of what happens with the approach to light speed, and this is that c squared thing in the mc squared, and so that's called an exponential. And basically, unless you're going really, really close to light speed, you don't experience any of these time shifts. They're very minor. They're very tiny time shifts. So you have to go really, really, really fast. And here's the graph showing that, and this is actually equal mc squared. Okay, the graph of E equal mc squared. But more importantly, the energy level you have to reach when it as it approaches light speed, your mass goes up to nearly infinite mass. In other words, before you hit light speed, your mass will exceed all the mass in the universe. Good luck. Okay. And then the second you hit light speed, your mass becomes uninterpretable, but on either side of that uninterpretability is basically infinity. So when you are going actual light speed, you're a divide by zero situation. So the way in physics that's in a modern way interpreted is, it's really your mass is infinity now when it hits when you're going light speed. The thing that gives you that mass is the fact that you had mass to start with. So in modern physics, there are exactly two types of, there's more than this, but there's relevant to 99.99% of your experience. There's two types of things. There are massless particles and there are particles with mass. And to be a butterfly, you have to have some mass. To be a human, to see, you have to have some mass. But to be a photon, photons have no mass, zero mass. So a photon can go light speed, and light speed times infinity is still zero. I mean, it's the mass is still zero. So a photon is ageless. So when a photon comes from 20 billion light years away, it sees no time change at all, which is crazy. People don't realize this in modern physics. This is how it's interpreted. And we have all the evidence in the world that this is true. But even the smallest amount of mass that you could have to be able to perceive anything or to do anything to go light speed means that you're going basically you're gaining so much mass that you outweigh the rest of the universe. And so way down. So if y'all look at the news on these things and you pay attention to, they'll say this object was going in space, some explosion in space was going 5% of light speed. 5% of light speed is down here. There's almost no time shift at all. Okay. There's almost no energy increase over what it was. And what's really going on is the only thing that light speed affects is a slowdown in time. It doesn't speed anything up in time. So you can't go forward in time. You can only follow your own path in time. And there, when you're going forward with respect to another object, to kind of return to it. First of all, to leave an object age appreciably and return to the object, you're going to become a fireball pretty quick, and nothing's going to survive that. Okay, if the aging has any appreciability at all. So,
Okay.
so we encounter this stuff in space now, but if you look at what they're encountering a couple of nanoseconds or a couple of billionths of a second of aging by a spacecraft that's going around the Earth. That's what they're encountering. They're not encountering the spacecraft aging, twice as fast as the Earth is. So this is an interesting situation, but people don't really realize what that equation E equal mc looks like. And once you realize what it looks like and how this works, and this article tells you how it works, Bradbury's whole hypothesis can't be done with massy objects. Just can't.
Good. All right. Well, thank you for that, Bob. We appreciate the insight into that. That kind of is a definitive statement. All right. Well, let's jump back to the case and see if we have other jurors ready to go. Well, we still only have 2 jurors. Okay. Well, we're just going to go with our 2 jurors at this point. Then, for the sake of brevity, we'll discuss the answers that they gave. So we're going to go back to our verdicts. We're going to look for juror number 1, juror number 2. Oh, here we go. Juror number 5 has come in. So we have 3 of the 4 jurors. All right, juror number 1. If you notice the icons here to the right of my name, plaintiff, you see there's a little copy symbol plus the word no. The icons down here are not exactly the same. Were they identical to that icon, I would know that they were identical to my answer, so I wouldn't have to look at them. But none of them are identical, so let's take a quick look. Juror number 1 says, is it the truth? Yes. Juror number 1 says, I certainly think the theory that killing a butterfly could produce huge changes. Well, he doubts any way to detect them. All right. And I think this must be yours, Bob, because it references the article we just looked at.
Yeah, and I think it's very plausible to say the butterfly effect exists. It's implausible to say that we could ever detect it on a scale that Bradbury was talking about.
Okay, good. All right. Juror number 2 says no, like I did, but with some differences. Let's see what juror number 2 says. The juror number 2 says the butterfly effect in chaos theory is the extremely sensitive dependence on initial conditions in which a small change in one state of a note deterministic model nonlinear system can result in large differences in a later state. Okay, now that's a good explanation of what it is. It was first made famous in the United States by mathematician and meteorologist Edward Lawrence. This problem motivated the development of ensemble weather forecasting. Weather forecasting is the systems that created are chaotic they are in chaos to speak of, and that's what makes weather forecasting so difficult. So what has developed here is you develop a number of different forecasts and look for a predictability horizon, which is kind of a summation of several forecasts or many forecasts, and you come into an area that's probable. That's established. But drawer number one or drawer number two says that cuts both ways. In a complex ecosystem, and the number of ways the death of a single butterfly could be inconsequential. You could step on the butterfly 60 million years ago, and its death would be compensated for by other factors. The plausibility of that is far greater than the number of ways it would have to it knocking down a series of giant dominoes. Now, drawer number two says plausibly. We don't have solid models of complex ecosystems today, let alone ecosystems 65 million years ago. So it could be true, but it's very unlikely that it would happen. Very good, drawer number two. Drawer number five says, don't know. Complex chaotic systems can evolve in unimaginable ways. The butterfly effect over billions of years may be scientifically improbable, but not impossible. That's pretty much what drawer number two said as well. Is it the whole truth? Drawer number one agreed with me. Drawer number two, you can tell they agreed because the icons are identical. Drawer number two did not quite agree. It's a sliver of possible truth, which should remind us of our ignorance about the range of consequences of even our most innocuous actions. Correct. Drawer number five agreed with me. Is it nothing but the truth? Everybody agreed with me. Drawer number five is a little different. Our current different probability, I think. He says that our current understanding about time is still crude and theoretical. Debating the likelihood of the butterfly effect and time travel is fun, but hardly scientific exercise. Yep. What's the deceit? Drawer number one says the deceit is that the lie is misleading. But even if it's false, it's undeniable that our actions have far-reaching effects. Drawer number two, it's science fiction. So declared untransparent untruth. We already know it's untrue. Drawer number five, different confidence level for drawer number five. Is the deceit true? Is it deceit or truth intended? I said yes. Drawer number two agreed with me. Drawer number one disagrees. No, I do not think it's intended. Okay. Drawer number five says yes, it's intended. Fiction, by definition, is not true, but I wouldn't characterize that as a deceit. I don't either. That's why I didn't mark it as a lie or a truth. It's just a statement to analyze, talk about. What's the motivation? Drawer number two agreed with me. Drawer number one, motivation is to be informative in a fictional way about something very likely, even if it actually can't be proven. Drawer number one thinks that it could likely be the truth. Okay, drawer number five, engrossing storytelling is the motivation, makes the reader think about unintended consequences. What's the social acceptability? Everybody agrees with me that it's acceptable, whether it's true or false. What label would improve it? Drawer number one says no label needed. Drawer number two agrees with me. Drawer number five, no label needed. It's a science fiction story, enough said, says drawer number five. Agreed. Okay, very good, everyone. Thank you so much. All right, so we got to talk a little bit about time travel. We didn't get to talk too much about how this functions as a literary plot device. We'll save that for another discussion. But I think we can all come away from this with the notion that in fiction, science needn't be accurate necessarily, or explainable, or even knowable for the piece to still be effective fiction. And I think Bradbury and almost every science fiction writer that has ever written proves that point, that the science is questionable, but the truth behind the science, if there is such a thing, or the implications of what the story is about, are still valid, whether or not the science is true. Science fiction readers have been saying this ever since it began.
And what I like about it is I really like this trial. This is a beautiful trial. The reason I really like it is we know, we don't think, we know we by Einstein, we can't prove this. We can't prove the butterfly effect in the general case. It's not possible. It's just not possible. Okay. And it just by the way, by the laws of physics. And so it's really interesting to realize that the way we can prove it is going to be a surprise, but it's not going to come out of physical our knowledge of physical reality. We can prove that you can't prove it, which is really interesting. So this is a piece of fiction that you know you can't prove for a very simple equation.
Good work.
Praise that stuff.
All right, everyone. Very good. Well, thanks, everyone. Thank you, all the jurors. And anybody else have anything they want to say before we leave? Okay. All right. Well, I invite everyone who's watching to head on over to truthcourt.net. Sign up if you're not a member. Run your own case. It's simple. It's fun. And you might learn something about yourself and learn about other people and learn about how you think about things and what determines whether they're truthful or not, or whether you need to know if it's truthful or not. Okay, thanks very much. Look forward to seeing you again. Take care, everyone.